Welcome to episode 3 of volume rendering fluorescence images with TIFF to Blender. We ended up with the last image with the last episode with this, where we had our masks visible, we had outlines for our quantification of our spots, and we see our separate strands of our masks that were also in our data set. And we had our camera set up, which could make a render. Now let's see if we can make this pretty and kind of and make a full video of how this should with annotations and everything. So one first thing is this is fluorescent data, and this is a lot of light in it. So I'm going to go to the background in the world and just make this black. This is how we usually look at fluorescence data, and we can then take from our volume. We can set our, because we're only doing one channel, it might be nice to just have this white. And we then have our things in white. There is one thing, that both the surface and the masks are only reflective materials. They only get lit by light sources in the scene. So here the only light source in the scene currently is the volume, because the axes actually just get rendered as a specific color. So instead we can theoretically also give them in the masks. We could, for example, give them a little bit of, I will go actually in the shading tab, we can give them an emission value, which will make that they also emit light in the color that they are. And then they're a bit clearer in this scene. And similarly, we can do this for our single spots. But we also cannot really see the single spots. So now we're going to do something that's a little bit more advanced and a little bit more specific for this data set, but I think it's nice to see that these things are possible. So I'll quickly turn off a few things to make it a bit more visible. So we have our single spots over here, and they're really hard to see. So what we actually want to do is we want to change the geometry that's actually in here. We don't want them just as a single spot, but we want them as something more complicated. So we can go into geometry nodes, and here we see how the geometry nodes work. We load in the channel 2 label masks, we set a specific material, and then we switch whether this is included or not, and then it's joined, and this is the eventual geometry of the masks object. So this is, and this switch is this switch. So we can do for channel 2, which are single spots. We can add a node. And here there are a lot of different things that you can, so here are all the nodes where you can, for example, rotate, move, anything, all of your objects or all of your points programmatically, and really manipulate how your geometries are being treated. So for this one, we're just going to do something simple, which is extruding a mesh. So we can put it in between here so that this mesh that was read out goes into the extrusion, and then it goes on into the same pipeline. And we can see that if we do this more and more, we get these stars at these positions. So essentially this just takes each face of the of the spot, and because it's a box, it just extends it out, which makes these stars. So just as a simple operation to show how we can manipulate meshes, if that makes sense for our data. So if we go back to our view, we could now still, even without our quantifications, we can still see where our spots are in space. So let's now also make our axes a bit more pretty, because while this rendering where you remove the front of the box is very useful for rotating around the data, this is usually not really nice for the export. So this is also in the geometry nodes again. We can set this to 1 micron per tick, so we get the actual full perspective. And we can remove the fact that we're removing the front, but then we see we have a lot of things in front, so we can just remove everything except the XY bottom. So now we just get a plane in the space where we see, oh, this is a 1 micron grid. This is how the perspective of the camera looks. Because if you do not have a grid, you do not know what kind of lens transform you might have on your camera, because our camera actually is currently a perspective camera. You can also put it in orthographic, which means that in depth everything will stay the same scale. So in this kind of space you can actually add a single scale bar, but this is a lot less intuitive for humans to see in 3D. So this is why I personally prefer perspective lens. And then we can tweak a little bit how this is. We can also tweak how big our output image is. So we can make it square because our data is quite square. And zoom back in with our lens. So this starts to look quite nice. We see we have a little bit of our spots. We see a very bright volume, which I'm going to reduce a little bit. We can also just make it less bright by just making it a little bit gray. And we can see our spots. We can even make maybe our spots slightly brighter so that they really show up clearly. And they have the same color as the synapthemal complexes they belong to. So this is, I think, quite nice. So two things that are kind of missing right now in this to me still is the size of our grid in the frame and the time scale, because we actually have time in this data set. I'm going to quickly intermediately save as well. So for this, we can add text annotations. And to add text annotations, we can add a plane. And this is just going to be, or you can add any mesh essentially, and say in the geometry nodes for the plane, I want to add a new geometry nodes modifier. And what this is so this is defining the geometry of the plane, is coming in, and now we're pushing this out as well. And we're just going to unlink that. Now there's no geometry going through. And we're going to add a string. So we can say 1 micrometer grid. And say string to curves. Where we put in this string, and then we get these curve instances, which then is in fill curve. And we want this to have we can now put this in here, and we see, oh, we have 1 micron grid. Currently it's a bit hard to render because it doesn't have a material. So we're going to make material 001 and also add set material 001, which we can just set to. Then we're going to scale this with S, and then we can grab it with G, and if we then press Y, we just move it along the Y-axis. Make it even smaller, and if we do G and then X, we go like this. And currently it's reflecting the light, so we can add emission to it, and then it's actually visible against the dark background. Similarly, we can do, I'm going to rename this to micron grid and copy this over now so that we have this again. And we're now going to make time. For time, we actually want to have a value, which we're going to do frame. So if we do hashtag frame, we get the number of the current frame, and we can do times 60, and then we just get our value in seconds, our number of seconds that have passed, and we can do value to string, and combine join strings. So now we can combine the value with seconds. So for finding all of these, how to do all these and what's all available in Blender, this is all annotate. There's a lot of YouTube tutorials, other YouTube tutorials out there, and there's also a lot of things on Blender Stack Exchange, and this is people just post a screenshot of these, how to make these kinds of node trees, and then you can just kind of copy them, and this is really effective. So I'm going to move this again with G and X. Can move this in the same space, but we can also rotate it 90 degrees around Z and move it to the other plane. So this will update with our time axis. And then one thing, because this is already really artificial data with all of our annotations in there, I might actually want to add, we are for the artificiality, because this is fun anyway, I'm also going to add a plane. I will scale up a lot and make a material for it. Set this to quite dark, and this now kind of reflects our light from our volumes and from our annotations. So this is fun, and that this kind of sets it in the scene where we're looking. And for this we can also, I wanted to maybe add the channel 1 volume back in, which we need a threshold. So that we actually see a little bit where our spots are. So this is just for beautification. This is also not the most maybe usable render for like just communicating the data, but this is to really give like a pretty output that we can then show in our presentation, like here is our beautiful data, and more to also show what all is possible with Blender. Another thing that I'm quickly going to show, but this is I think less that I'm probably not going to include in this, but this is just to say how these things work, is we can animate most objects, any value that you kind of see, by setting a keyframe at a certain position in time. So if we go, for example, in layout, we have our time axis here at our bottom. I'm going to zoom this in a bit. Of 10 frames, because this data is only 10 frames. And we can say, let's set at our 0 frame, we set our slice cube to be at a specific location. And then at frame 10, we see that, so, and we press, sorry, what we did here, we set it at this location, and we say, if you hover over something and press the I key, this sets a keyframe. So this will turn it yellow. It also helps, you can also click all of these separate things. Then if we go to, for example, the final frame, and one of these values is changed, we can set a new keyframe, and then it will, through this time axis, interpolate these values. So we can, I don't think it's really relevant for this scene to have this, so we can just set it back where it was. But similarly, you can also animate your position of your camera, the opacity of certain objects, your volume thresholds, your so any value essentially in Blender that is just a floating point value, you can animate, and you can then it automatically gets interpolated over time. And with this is also that you can actually change all these animation, how the interpolation of all these animation things happens as well. But this is for a more comprehensive Blender tutorial, and there's a lot of just animation making Blender tutorials that will help you with this. But now we have, for our time axis, our data set. And I'm going to render this, which will be, so we'll make separate renders for every frame, and these will be placed in wherever in your preferences your render folder is, and then you can compile these together with something like FFmpeg. So thanks for following along with the tutorial, and here is the final render.